So I'm going to be talking about FormFactor's position with cryogenics in the quantum marketplace. So real quick, FormFactor has been publicly traded since about 1993. They've been a mainstay in the semiconductor industry. Over the last 12 months, we've done about 800 million in revenue, and we have about 2,300 employees worldwide. So today, though, I'm going to be focusing on the cryogenic test and measurement portfolio, and then some of the recent developments in terms of what we're doing for deployment for the quantum marketplace. So our temperature solutions really span from 300 Kelvin all the way down to about 10 millikelvin. In addition to those test and measurement systems, we also have a suite of probe cards, engineering probes that can be used anywhere from small scale lab R&D all the way up through niche production and complete volume full scale wafer stuff. The quantum and cryogenic part of the company right now has a couple key areas of focus, which includes things like superconducting and spin-based qubit devices, CMOS-based devices, as well as components that are required to support the entire quantum computing chain. And we also do some work in the photonic device world. So again, looking at the full product suite that I'll be talking about, I've previously presented on the ADR cryostats and the chip scale probers, including the fully automatic wafer scale prober. And then we have a full suite of products that include things like probes, probe sockets that can be used with all of the cryogenic, the product line. But the newest development from FormFactor is the dilution refrigerator technology. So now we are the largest US-based supplier of dry dilution refrigerators. This comes through a recent acquisition that happened a couple months ago. And that dry dilution refrigerator product line has base temperature below 10 millikelvin. We have solutions up to about 500 microwatts at 100 millikelvin. So I'll show a little bit more about that. With FormFactor backing the dilution refrigerators, we're now also able to offer, I think for the first time to the market, financing options. So a lot of times these fridges come with very high capital cost, and FormFactor is able to provide flexible pricing solutions for everyone that ranges from academic labs to startup quantum computing companies to the leading qubit developers or quantum processor developers. We also have an extensive service and support network. So I mentioned that FormFactor is a worldwide company. So we're bringing up the entire network in terms of being able to support the dilution refrigerators and ensure maximal uptime. And then the largest fridge that we're offering right now is a 600 microwatt at 100 millikelvin fridge. We have solutions for complete RF signal chains. And then the manufacturing center for these dilution refrigerators is headquartered in Woburn, Massachusetts. So everything is produced in the US here. So that's the newest product. Shifting gears a little bit, I'll talk about our cryogenic test and measurement service. So this is housed in our advanced cryogenic lab in Boulder, Colorado. And really the impetus for starting this was that we saw a problem in the cryogenic world. Essentially, cryogenic systems come with a very high capital cost and very long lead times. Many customers need faster access to data. They don't want to suffer through that long lead time. Or they need to try a new measurement and see whether or not the value is there for them to explore that in a deeper way and really invest in that. So that's really the start of the cryogenic test and measurement as a service. So this provides customers with immediate cryogenic access. So they can either use the large scale fully automated wafer prober, which is up and running in our Boulder, Colorado facility, or they can work with one of our millikelvin testers, whether it is an ADR system or a dry dilution refrigerator. Here's a little bit more information about the fully automatic wafer prober. So we've seen several use cases come from the leading developers out there. Right now, the system is being used for statistical process control, especially for looking at the scaling of devices, whether it's a spin qubit or a superconducting qubit device. A lot of preliminary measurements are made on this type of system, including your basic S parameter measurements on 4K niobium resonators. We've looked at JJ resistance, and then just due to the large amount of data that can come out of a system like this, a lot of companies are starting to develop machine learning models that will allow them to draw correlations between what they can get at higher temperatures and the data that they would see at lower temperatures. Here's an example of some of the measurements that have been performed. The data shown here was a collaboration with MIT Lincoln Labs. So we looked at a variety of measurements on wafer, including things like SQIF-B field on the wafer, inductance versus unit length, the JJ critical current, normal resistance, and gap current. In this particular measurement, we looked at 24 squid-based test circuits. If you would have done this on a typical chip prober that you would see in the cryogenic world at an academic lab or an R&D facility, something like this would take well over a week to fully measure all those devices. With the Wafer prober, we're able to do that in a single cool down in about 5 hours. So again, a very high volume of data is coming out of the cryogenic Wafer prober, and we do have a Wafer prober that's being offered to the community if they want to try that out. The last solution that I'll touch on here is the millikelvin cryostats. What's shown here on the screen is an ADR cryostat, but this could equally apply to a dilution refrigerator. And what we're doing is we're pairing our PQ500, our probe socket technology, with the millikelvin test environment. So customers can take this device, skip wire bonding, skip packaging the device, and you make direct contact to the device with probe tips. That gets plugged into a socket in the millikelvin environment, and then you can perform the basic characterization measurements on a quantum processor. So this is being used for qubit and resonator characterization, process control, as well as materials development. And we're also offering these systems to vendors who are looking to qualify components in the signal chain. Things like RF amplifiers, HEMPs, circulators, isolators, other filters, and that sort of thing. So with that, I'll conclude and just say that FormFactor is here. We're focused on customers and enabling the quantum market, both with millikelvin deployment and our test and measurement solutions. So we're excited to work with the community, and please bring your use case for discussion here.